In this video, we begin our discussions of surfaces in space, beginning with what is called a cylinder. Up to this point, you probably think of a cylinder of like an infinite Pringle can or something that is circular or like a soda can or something like that. Right, this is so far we think of cylinders. If you can tell what I'm drawing in 3 dimensions, they are trying to. Um, we we've called cylinders that up to this point. What a cylinder actually is a shape that goes infinitely in each direction, um, like at a constant. So it's like, notice that this is a circle. At any point going up and down, I have a circle. It's just like everywhere continuing. A cylinder is something, could be any shape that has that property of like going the same shape infinitely up and down, creating that infinitely long, like tube-like container. Okay, so a couple things. Let's go over definitions of what a cylinder is. Equations that only have two variables, and they give what is called a trace. And we'll work with the trace today. You'll see what that is. The curve on the coordinate plane denoted by the given variables. All right, the curve is directed along the axis of missing variable. The curve/trace does not change along the direction axis. Okay, so what they mean is, notice that this equation has two variables. So since it has two variables, this tells me that it is a cylinder. All right. The trace, so the graph that's actually drawn, so you can see that there's an x and a z. The trace is going to be on the xz plane because those are my two variables that I have. And then this cylinder is going to be directed along the y-axis, the missing variable. All right. So first, let's talk about what the shape is before we get to the graphing. This is, hopefully you can, the Z doesn't throw you off if that was a Y. This is just an algebra curve. So this is a parabola, All right, and I don't know if you guys remember your transformations, but we got negative x squared plus 4. This is a parabola shifted up 4. Shifted up 4 units on the z-axis and opening down. And we don't want to use down because up and down needs a reference. Let's use opening towards negative. We'll do this as negative z-axis. So it's pointing down in our picture, but that's all we have. Okay, so there is a way, a grapher. I'm going to graph here in a moment. I'll attach a, we'll graph it. I'll go ahead and graph it in this video. Okay, so what we're going to do first is, I know that that's a parabola on my xz axis. So notice my x is here and my z is there. So I'm going to graph that parabola. So it's up 4 on the z-axis, and then it's turned over. I'd like to know where it crosses the x-axis, so I'm going to take my equation, which was 4 minus x squared, and I'm going to set it equal to 0, and that's going to tell me where it crosses the x-axis. All right, so that's plus or minus 2, just a little bit of algebra there. So I know the parabola goes here and there, and I'm going to do my best to draw it. My art skills are not great. All right, so there's my janky looking parabola. All right, I think I can do better on the left side. All right, there's my parabola. All right, and what this is going to look like is we're actually going to have a parabola extended across our screen. So let me take one more thing. I'm going to make this back line here if it'll let me select it. Let's go ahead and I'm going to do this one as a dotted line because it's going to be on the back side. All right, so this parabola is going to be on the back side, this part. Go. Right, and then what I do is, okay, I know this parabola it's on the x-axis, even though it's kind of hard to see in 2 dimensions, but it's living on the x-axis there, xz plane. So I'm just going to put a whole nother parabola. I'm going to use a trick here to kind of help, because it'll help with seeing it correctly. I'm going to duplicate this And I'm just going to put it right along with it. And you're going to do the same thing, but you're going to sketch it, which he did. All right. So now, if I take a line and I connect it across, let's not do dotted for this one, and I connect it across all three. There's the top of that. All right. Then I have this thing. And then I'm going to put a dotted line to represent that backside. So this is like an infinite hill, maybe going on in each direction. We have that parabola in the middle. All right, let's try to graph this in an app here. So let me see if I can pull up GeoGebra on my iPad. I'm pretty sure there's an app. There we go. Of course, it's going to update right now. So we'll let that load. Thank you guys for letting me include this in my video. Sorry for the background of my Futurama screen. I really thought this would be a lot quicker than that is going. All right, while that's downloading, let me set up my keyboard. So we're going to type this in. So this grapher, it's GeoGebra. There is an app. There also is a website that you could use. All right, so here's GeoGebra. Looks like this. So I'm going to type in z equals 4 minus x squared. And there we go. We have a parabola. Now, it looks a little different because they have y sticking out at us. So we'll do this. This would be x sticking. There's our picture. Oh, let me flip it around. So you can see the parabola there. Here's what our picture kind of is supposed to look like. Not too bad. I guess it would be more like this. All right, there we go. So that is our parabola. There was my best interpretation of said parabola. I guess this line would need to be probably parallel, and you could bring things down and make it look better. But you guys get the gist. I will not be ever grading on your art skills. Just do you know what it's supposed to be, and you can piece it together. I have ways to test you on this to make it a little more fair than basing it on very difficult sketches, because obviously mine are not great. So yeah, I can't hold you to an art standard if I can't even meet that standard. Okay,